Okay, our last topic in application of the derivative is going to be to our economic settings. We're going to take a look at our cost function, our revenue function, our profit function, and then we're going to also specifically talk as it relates to calculus and marginal revenue, marginal cost, which are going to be our derivatives of our cost function, and the derivative of our revenue function, and how it relates to profit. And obviously, for profit, what you want to do is you want to maximize your profit, and so that's what we're going to be taking a look at. How do we maximize our profit, and what is it going to be what number, how many iPads should we produce, or how many iPhones should we produce to maximize our profit? So the cost function is given to you as C of x, okay? And the average cost function is going to be the cost function divided by how many you're producing. So if you have, let's say you're producing 10 T-shirts, and your total, your total cost of producing those 10 T-shirts is $80, then obviously your average is going to be $8 per shirt. Your marginal cost is the derivative of the cost function, and what that means is that it's the approximate cost of producing one more of whatever you're producing. The revenue function is given as R of x, and that's how much you can sell for. And it's not like each shirt. The shirt is like how much you can sell each shirt for is the price. But if you sell, let's say you sell those 10 shirts, and you charge $10 each for them, then your total revenue is $100. The marginal revenue is how much revenue, approximate how much more revenue you'd make if you produce one more. The profit function is the revenue minus cost. Obviously, we want that to be positive. And then the key concept as we get for calculus is that to maximize our profit, or maximize, that should be maximum profit when your marginal revenue equals your marginal cost. Let me fix that because that's an important subject. I must have, again, typo. This is going to be maximum profit when your marginal revenue is equal to your marginal cost. That's where those two tangent lines are going to be parallel to each other and greatest distance apart. So let's look at a couple of examples. Let's say we have a company that's producing components used in electronic toys given by 200 plus 0.05x plus 0.001x squared. And we want to find the cost, the average cost, and the marginal cost of producing 500, 1,000, and 5,000 units. So let's set up a little chart. So let's go units, and let's go cost, average cost, and marginal cost. And we have 500, 1,000, and 5,000. Now to get the total cost, we're just going to put 500 into the cost equation. That's all we're doing. So we got that to be about 250 for this. The average cost then would be about 50 cents, or about 0.5. And the marginal cost would be about 0.15. That's the derivative at 500. For 1,000, we got the total cost to be 350. We got the average cost to be about 35 cents. And we got the marginal cost to be about 25 cents. And then finally for 5,000, we got $29.50. And the average cost of making those are going to be 59 cents each. And the marginal cost is $1.05. What you're seeing here is that as there's an optimal amount that we want to produce based on this given information, because if I start producing more, then I got to pay, may have to pay overtime or whatever. And then the idea in the second part is that we want to compare the marginal cost of producing 1,000 units with the cost of actually producing the 1,001st unit, which is, remember what the marginal cost may be. So the marginal cost at 1,000 units, which is 25 cents, is going to be how much approximately more would it be for me to produce one more of these little electronic things. So what I did was I figured out the cost of producing 1,000 units, figured out the cost of producing 1,001 unit, and I subtract away the cost of producing 1,000 units, and I got that to be almost exactly 0.25. And what you can see is that that number is virtually the same as that number. Sometimes they're going to be further apart. It depends on how close the tangent line is to the graph at that particular point. A second example, we're going to take a look at how to maximize our profit here. So we want to write the revenue function. What we have is electronic company producing calculators. Here's the cost, and each calculator is sold for $18. So we want to find the revenue function, R of X. R of X is how much I can sell the calculators for. So that's going to be 18X. It's $18 for each calculator, and X calculators sold. The profit function is going to be the revenue, 18X minus the cost. Make sure you subtract away all of that. And then remember, what's the daily production that will maximize our profit? What I want to do is, my concept, or the way I learned it, was to take the marginal revenue equal to the marginal cost. So the marginal revenue, R prime of X, equals the marginal cost, C prime of X. In our case, it's going to be 18 equals 6 plus 0.04X. And if I solve that simply, what can happen is that I should produce about 300, or whatever electronics I have. And then the maximum daily profit, I'm going to take that 300 and I'm going to put it right back here. So I'm going to get 18 times 300. And I end up with about $1,300. So this part right here is $1,300. So the key concepts here are marginal revenue, marginal cost, and then how to maximize profit based upon marginal revenue, marginal cost. Okay, well, good luck on this, and then we get into the review for the final exam. We take the final exam in January, and after that, then we get into our second semester stuff, which is on integration.